till the end of the project, so the developments are ongoing. I saw a lot of good also data sets on the historical ignitions that you have used. We're going to go back to that during the discussion. And we have now a different kind of project. We have a USAT Finder project with us, Marco Nisi and Alberto Topini. I don't know if both of them are with us now or only Marco.
Yeah, can you hear me?
Yes, Marco, we can hear you, we can see you. How are you?
Yeah, fine, yes. Sorry for my colleague, for Professor Tofini, cannot join, but yes, I can cover by myself also the other part. And okay, so unfortunately.
Also, USAT Finder is an ongoing project that we have in our portfolio, a little bit different thematic, but we're quite interested to hear the current development. The floor is yours. You can
yes,
share your screen now.
I'm trying to share. Yes. 1 second.
Yeah, I can see something coming. Yes, I'll put it on.
It's coming?
Okay. Yes. Yeah.
Hopefully. Yeah.
Perfect.
Okay.
Thank you.
Yeah, first of all, Vasilis, Serena, thanks for the inviting, to this interesting AI week, so that we can have my contribution together with hearing from other projects, yes, for a potential dissemination together. So nice to hear, and also to provide my contribution. I'm Marco Nisi. I'm the head of the Department of Integrated Solution in Systematica. As I said, I prepared this presentation. Also, I support the Professor Tofini for University of Florence, which is the real expert for this particular subject of AI, and I would like to publicly thanks Alberto, even if for personal reason cannot attend today. Okay. So, the outline. I would like to introduce the concept, the project status, with a particular focus on the connectivity and application layer of USAT Finder project, and to have a second part more dedicated to our usage implementation of AI, which is for targets, identification, characterization and localization, explaining the rationale, our analysis for the design, which is at the current status of project of CDR, together with presenting some data set with preliminary performance sharing of our solution. Okay, so USAT Finder, what is the USAT Finder? Is a solution in order to support first responders on the site, so meaning fire brigades, civil protection, together with medical assistance, which are operating both on the field, on the area, during the tactical phase, during the response and the second part of the recovery and mitigation for the emergencies. We have for sure a participation with the preparedness, with a contribution of the usage of Copernicus part also. But the main focus is on the response and the recovery section, where the actors involved, the first responders, need to go to the site. Accordingly, the consortium is composed by Systematica, the company I'm representing, which is in charge of the end-to-end application, the end-to-end solutions, supported by Telespazio and CNES for the connectivity of the SATCOM, as well as also Eversat, which is in charge to develop a dedicated SATCOM terminal. There are companies involved in the drones usage, entry system, TSP, Atmosphere, and we are also covering cybersecurity part, because in our project we are integrating the terrestrial infrastructure, a proprietary one, where we are going to the site, potentially integrated with the already existing, if trustable and available, and for sure in connection with the satellite connection. And we are also in the consortium, the end users, represented by the Civil Protection Center of the University of Florence. I think, yes, alerted anytime there is an hazard in Italy. There is the Regione Valle d'Aosta, And in particular, we are a demonstration planned in 2027 in Valle d'Aosta, also in collaboration with the Sécurité Civile, the French also actors, and we are starting to prepare a scenario also in order to test for the operational aspects, relationship and inter-collaborations among different actions on the site. Okay, the page of the project where you can find more information is usatfinder.eu, so I think you can surf on the internet and you can have a lot of information on the website. As I said, just to say where we are, so we are at the CDR, meaning that during that period we completed the specification of our solutions, which is focused on the secure SATCOM and integrated terrestrial network on the site, considering all the possible connectivities. But we have also a special focus, activities 3.4, which is on the first responder application, which is in particular devoted to share several data, considering in particular real-time videos, and that's here that our AI activity is focused in order to have real-time detection, localization, and and alerting, so the management of the phase, of the active phase. Okay, so as I said, we are here and we started just our initial development planned to be concluded end of this year, having the TRR on July. Okay, before coming to the application part, which is the focus of this contribution, the today contribution, just to better introduce what we are going to propose. You can see on this connectivity presentation two sites. Potentially one should be in Valle d'Aosta, the other one is on the boundary on the French area, the Haute-Savoie. And we are planning an organization. This is during the tactical phase, as I said, for the responsive and the recovery phase, so that first responders are planned to go on the side with special vehicles, what we call the MOC, Mobile Operational Control, which is the local headquarters where our application are installed with the 3 desktops, workstations. First operators are operating on the site also with we call mobile app. Generally we expect mobile phones, which is the other node, and also we expect contribution from citizens, which can be on our private network for both localization in the case it is possible, or even to contribute having a dedicated network and after a check providing information by themselves, which could be basically picture and videos. So the idea is to connect at least 2 sites, and an important part is devoted, as I said, to the SAT part, so that in the case the terrestrial network is not trustable, not available, this site is anyway connected off-site, as you can see the remote department, RHC AP, where decision-making people are basically to be connected with the site, possibly by using terrestrial network or through the satellite chains. And in the framework of GovSatcom, we are including 2, I should say 3, because Athena Fidus, which is a governmental satellite, French and Italian, civil and military, but there are 2 different payloads, so for us there are 2 different sources, as well as Eutelsat, very high throughputs connect for the fixed communication, FSS, and also the drones, in the case they are not in direct connection, on the direct RF connection, they can be reached by 2 operators operating in GEO MSS and LEO MSS. This is to share command and control, but also mission data, as I said, which can be picture, which can be used also for post-processing, but what is really important is in real time, so that we can get videos considering, yes, the data throughput and latency. In this picture, you can see that we have at least 4 nodes, as I said, for our application, which is a distributed application. First one is the MOC AP on the spatial vehicle, mobile phones for the first responders, citizens, and the connection with the remote site, which should be basically the headquarters of the first responder, which could be civil protection, fire brigades, etc. And the remote connection is also used to access to external services as Copernicus, to be used in the site along with if the activities could last even more than several days. An interesting part also is the connection with the U-Space, so that the drones are directly connecting using the SATCOM link to share their location. Okay, this is the overall pictorial. Now, coming the application, as I said, 4 nodes. This is just a preliminary picture. As I said, we are not yet developed the final user finder application. They are a potential mock-up. As I said, 1 node is for the first responder decision making, which needs to have only high-level information, dedicated information to perform decision in the chain of commands to inform the MOC AP, which is the central nodes where all information are connected, so data coming from the drones, for the mobile operators on the field, and with the dedicated network also having information from the citizens, as I said, location where needed for safety reasons, but also citizens are considering in a community approach part of the solution, provided the correct verification of the information provided. Okay, having in mind this framework, now the focus on the AI. So our approach on using AI is a contribution to the analysis of particular real-time videos which are collected. We have in particular 2 phases in parallel, for sure, real-time. First one is the target detection. We call also classification, but according to the nomenclature, detection includes classification, which means to detect a target and also to say what is, which could be a vehicle, people, or also some events, as it is indicated here, fire. We are using an evolving YOLO version 11, and for detection we used the overall pre-training performed by YOLO, which 20,000 samples, but which is not enough for our information, because in order to detect other events as the fires, we also complementing this training with the dedicated data sets in order, yes, to add additional elements. In particular, in order to prepare this presentation for this week, we focused on fire detection. Second part, we would like also to localize and to put in a map the detected targets, and this step can be performed in considering 2 approaches. First one is the geometric and heuristic method, meaning that in order to have this information, you need to have all the camera information, and the analysis of the scenario is performed by indeed geometric analysis of the considering the information of the camera, focal point, focal distance, etc. And this is one point. But and this is the real part of our interesting activities, which is research, but with really interesting information, is using the other approach, which is transformer based, which is completely independent from the camera used, meaning that by analyzing AI analysis, and we are using depth anything. Now we are checking version 3, start moving from version 2 to version 3. And what is possible is to have an estimation on the depth, only analyzing the video which is coming, okay, provided that there is a training on this stuff. So now I'm presenting you two samples get from the internet, so which are not used for our training. So the training is performed, and based on that all the information about detection, classification, localization can be analyzed. And okay, the two cases are: the first one, we are imaging an indoor, so that we are interested to detect mainly human people, and you can see the files. We have information of the angle, which is quite easier to detect, but the most difficult is the distance. Okay, up to date we can know we don't have the reference to the true for the localization, because as I said, this source is coming from internet. But if you have a look from the relevant distances, you see that the field of the camera come from 15 meters on the close part. Maybe there is one part where people is coming far too close, yes, maybe 18, 19, till 30 meters, which is an interesting yes, coverage, considering yes, indoor. On the far, due to the smoke and also the distance, the detection is not easier, but this is not an issue, because we can even put another camera. If with one camera we can cover 30 meters, I think yes, it is a good result. According to the configuration, the detection is over 70% of confidentiality to avoid the false alarm. And yes, so yes, maybe also the quality of the video is yes, not so good, and this is important because in some cases in this scenario, due to the limitation in bandwidth, we can even manage low quality video, even in the case we are not using fixed cameras. Okay, and this is a first one scenario where okay, yes, where we were focused on people, and yes, the good point for in terms of performances, we need to check about yes, the configurations in order to improve even some detection not yet included, but yes, this is the result today as we are in CDR. Second scenario, we are imaging, and this is still a video coming from internet where we don't know the characteristic of the camera. We can imagine that this video is kept by a UAV, maybe a rotary wing, moving in a circular trajectory, trying to have on the center the fire, which is located around 120 meters. This is what we can imagine, and yes, this is also in terms of performances. One point I didn't say in the reason why we selected YOLO is because there is the possibility to fine-tune depending on the hardware we have. This analysis has been performing having 32 gigabyte of RAM for the GPU, which is the most important part for this kind of application. In this case, you see a lot of targets, so we have to reason what is the better in terms of confidentiality, because even if these data are registered on the database, so there is not the human perspective to have collection, to have the analysis of data. Maybe we need still improve yeah, the user presentation, which is one of the point on under discussion. In this case, the range is, which is the distance point to point from the drone, which is moving, which is more complex with the previous example. Yeah, we have a distance around 19, so reaching 130 meters. So yes, this is let's say not a quantitative yet, but a qualitative analysis, and I think that this kind of approach is quite interesting. Also because, as I said, according to our architecture I was presenting before, we should manage several sources. In several cases we know the characteristic of the camera, but in the majority of the cases the only information we know is the point of the video is taken, which help us to translate as a second step this information you see in this video in a map. Because if we have the position of the observing point, we have the distance, the angle, and okay, it's quite easier to put in a map on a 2D map in order to have you know, the scenario to take decisions. Okay, so yes, that's all on my side.
Thank you, Marco. We understand that you have still time for development on that, and I've seen some nice videos as examples, but I can imagine, and I'll pass little by little to the discussion, there is a difficulty to find, you know, training videos for whatever development you do, right? Particularly in the environment that you talked before. You talked about Valle d'Aosta, and in contrary, the videos we see are, you know, cities and indoor environments. So how do you deal with?
I have to say that there are public data sets, so okay, not too much, but okay, there are also the possibility that there is a work from the community also on this stuff. The difficulty when it comes to training is to use you know, real-time data, paying attention to GDPR, you say, because we are not in an operational environment, we still don't have authorization, and yes, this is a research we performed in a few months, I should say weeks, maybe, and we should be able to find something related to files. When it comes to enlarge to other hazards, maybe we need to check. But this allowed us, as I say, sorry to come back to this point, to test the approach which is independent from the camera, which is for our application a real, you know, not killing application, but you know, very important considering our perspective.
Okay, thank you very much for the presentation, Marco. We'll pass a little bit. I see some questions there, so that's why I say to the other presenters if they could stay a little bit with us. The first question of Miguel was about the presentation. I responded already on the Q&A box that indeed we plan to share the slides after the end of the week. So this might take a little bit of time, but we're gathering all the material and we will be sharing those with you. Next question, I think it talks about use case 2B, and I think this is for Unicorn. I don't know if it's Martin or Marisa. I can read it through. It's about the fire and how do you handle the class imbalance between fire points and no fire points when you train, and how do you validate basically the performance? This is a question I wanted to do as well, but Jagmur took it for me. Go on.
Yeah, it's a very good question because it's something that we'll have to think about that a lot. And the thing is that we're dealing with emission points, so it's not a gridded data set, and we wanted to do it like that. I mean, to keep the non-gridded nature of the data set. So at the end, you don't know the natural imbalance of the data, because what is a non-emission point? It's not something that you cannot define that, right? So at the end, we fixed an imbalance. We used, I think, the 35%. And so we create like non-ignition points stochastically and fill the data set with that. And so, well, we did applying a buffer so you don't get a non-ignition point very close to an ignition point. But the thing is that you get some metrics with that you are using to train the model and test which one of the configurations for the hyperparameter training has a better performance for the data set. But at the end, you have some metrics that you know that in a real case scenario where you will have like a natural imbalance that, again, you cannot properly define what it is in this case, but the metric will go down, you know that. But at least you can do that for choosing your configuration. And so this is a part of a whole system. At the end, what we want to do is a proper validation for the final result. You know, for the probability maps comparing with satellite images. So yeah.
How big is the historical ignition? You showed Portugal and Spain, and I think there's quite a lot on the community, also on the practical side, to find these data sets, which usually are with institutions. You mentioned in Portugal and Spain. How big was this data set? Was it a couple of years? I saw many points, but I don't know if you mentioned it. Sorry if you did.
No. We have that from 2001 and 2015.
Okay.
That is because we used some national databases, one for Portugal and the other for Spain. We also have to merge those data sets because they were like, you have different thresholds for fires. You know, in the Spanish data set you have ignitions above a certain fire size. You know, and for the Portuguese you will have like much more ignitions of very small fires. So you have to deal with that also. And the Spanish data set is only consolidated until 2015, I think, so that's the limitation. For the most recent years, and yeah, that was also a difficult part to merge both data sets.
Merge and work with this training data set. Yeah, that's what I hear from the community, and I think, I mean, the projects we have tried to find various ways, mostly through the users that are involved in the project, or vicinity, let's say, to certain public organizations, as in your case, you're based in Spain, so you have closer connection to the authorities to get such data sets, which are quite important, also and have an applicable impact to the solutions you're building. There is a question maybe for Overwatch and Unicorn, and that was also something I wanted to ask, because we speak a lot about the technical development, but on the practical side, someone who will be responding on such kind of like wildfire flood events, in the case of Overwatch, will think about timeliness, how quickly we can do that. This is the first question, I think. So I don't know if Eduardo or you, Davide, touched upon the timeliness. Have you benchmarked how quickly these Overwatch maps can be created in cases needed?
We did, and I was in the background. I was looking through the deliverables where we put these figures because I couldn't recall. This is a question we get a lot because, as you said, first responders are interested in the timeliness aspect. And one question we always gather is also about the fire: is can it also be activated during a wildfire? Which is correct. The answer is no, because of smoke. But in terms of delineation abilities, it's from a matter of seconds to a matter of minutes. We benchmarked, in Overwatch, we benchmarked up to 100 square kilometers, and it was under 1 minute. We also did some stress tests, mostly not to verify the timeliness, but to verify system stability overall. and we mapped basically the northern part of Portugal in 30 minutes. So so if you have a single Wi-Fi to map, is a matter of minutes, and the slower part is not the inference, because that we can scale. It's the download side. Even so, we managed to have several sources from Microsoft Planetary Computer to Copernicus CDC, so that we still cover a broad spectrum, and when one service is not available, we have a fallback. But yeah, the data availability and retrieval is still the slowest part, which is a bottleneck that with time will be even less predominant.
Yeah, because you count benchmark from the moment the image is available, which is not always.
Exactly. With Sentinel-2 is 1 out of 5-6 days, and we are using L2A, so we are now trying to use more sources for fire detection, going to less processed products like LLM products and so on.
But do you use the same models for extending beyond Sentinel? I asked the same question, I think, yesterday when we had discussion about foundation models. How you can the high resolution sensors?
We are trying. We don't have a solution yet. The problem is always the retrieval. So for fire delineation, the problem is most of the time authorities and first responders and other people in the environment use very high resolution data, which is tasked, and then it needs to be accessed some way. So in that case, the only solution we are currently using is to train not on wildfire detection itself, but on models that work also, that can extract features from other satellite sources. And then hopefully, if the model produces satellite agnostic features, we'll be able to work regardless, even if we train on for the downstream task is only for Sentinel-2. If the features are really satellite agnostic, it should work theoretically also on other satellite sources, but we are still working on that too.
Okay, thank you, Eduardo. There's a question for Marco by Marina de Souza, about the connectivity system that you showed, Marco. I don't know, Marco, if you can hear us. It is similar to the ones used in the Waze or Google Maps to check the traffic information such as accidents, radar, etc. The people can add their input to the system by themselves. So basically the question is if it has this functionality of your community input into the system, but I don't know if you have reached in the development this kind of
maybe okay, thanks for the question. Maybe it is referred to another possibility, but in terms of approach, indeed what we are prepared is to manage different sources, having as a first point the need to check the input which is coming for the quality and also for the security reason, because if we open the connection, yes, we need to check, because there is a dedicated infrastructure used by the first responder also for communication, etc. But maybe, yes, the comparison is with the approach which is the community driven. In our approach, we expect that citizens, which are in a first step before the hazard, which are we know about user finder, can download by repository, the public repository. I mean Google or also for iPhone, yes, for the mobile application. They have the application on the site, they have registration, and in a case they are in the site and they could access either on via public terrestrial network, because we can be reachable using the SATCOM or the terrestrial, or by our proprietary network. The approach is to use their contribution, two steps, I should say. Their contribution, because they could stay in a dedicated location, not yet reached by first responders. So we have other sources, and one time they are in a network. In case it is stable, they could share also their position, their location, which is for safety reason another approach on on our solution. So for this case, but coming to the question. Yes, we are going to exploit the community approach. So having as much as we can the sources for a better knowledge of the scenario.
Thank you, Marco. I see I'm trying a bit to formulate also the questions that we get. Thank you for the presentation. I found them very interesting. I have the following question. I think it regards Overwatch and Unicorn. In the case of fires, flooding, image resolution and latency are critical factors. We discussed a bit about latency. I believe you mentioned that the image resolution would be around 10 meters, but what would be the latency? I think we have just discussed that. Additionally, could the use of AI help reduce latency times? In flooding scenarios, these delays are especially critical. I think, Eduardo, maybe in your answer, you have covered this part.
Yeah, I don't have much to add. In fact, just say again that the most important problem at the moment is not the AI part, which produces an output in
The
seconds
availability
even.
of the
It's
image.
really the data. If the data is not there, we cannot really produce a faster map. That's the main issue.
Okay. We still have some minutes. If anyone from the people online would like to pose a question, I'll leave for some seconds still the floor open.
I am reading a question about if the prediction
Yes.
about the past.
I think we didn't cover that part. Yes. If you would like to.
Yes. The point of the system is to be flexible to on-demand mapping. That means the user is provided with a start date, end date, and draws on the map an area of interest. This start and end date can be both in the past, both in the future even, or a pre and post event. So the task, if in the future, is scheduled to be executed once the end date is available, basically. And if it's in the past instead, it gets automatically processed on the spot. So as soon as the request is ingested, if both dates are, for instance, 2023, the model will be activated on the spot, taking the image, and that's it.
Okay, thank you, Eduardo. Let's do another check on the Q&A box. Okay, I don't see anything new. I would like to thank you all for the participation, for the contribution. Thank you for the questions. We covered some part, as I said. We have more projects in our portfolio which regard crisis management and do have some kind of AI development inside. Excuse me. Today we were able to hear from Overwatch, Unicorn, and EUSAT Finder projects. You saw a lot of examples of how AI can be applied on burn area detection, on flood delineation, on damage assessments. We saw quite a few examples also on the case of EUSAT Finder, where Marco presented the whole system and the approach of the project, but also he showed some examples of the development they're putting together for in the case of responding to the environments and the use cases of drone imagery. Tomorrow we have the day 3 of the event, which will